Welcome to Mind Map MCQ. In today's video, we are diving into the heart of our solar system, the Sun. We will explore its various layers from the core where nuclear fusion powers its energy to the surface and beyond. Whether you are preparing for competitive exams or just curious about astronomy, this video is packed with engaging multiple choice questions to test your knowledge and help you understand the sun's structure and significance. So prepare, practice and prevail. Which of the following two elements are the primary constituents of sun? Hydrogen, nickel, helium and oxygen. The options are A 2 and 3, B 1 and 4, C 3 and 4, D 1 and 3. The correct option is 1 and 3. The sun is primarily composed of hydrogen, about 74% by mass, and helium, about 24%. These elements dominate its composition, with trace amounts of heavier elements such as oxygen, carbon, neon, and iron making up the remaining 2%. Question 2. What process powers the sun? Options are A. Nuclear fusion, B. Nuclear fission, C. Chemical contraction, D. Gravitational contraction. The correct option is A. Nuclear fusion. The sun is powered by nuclear fusion, specifically the fusion of hydrogen nuclei into helium nuclei. In the sun's core, where temperatures exceed 15 million degrees Celsius and pressures are immense, hydrogen atoms collide and fuse together, releasing energy in the form of photons, light and heat. This process, known as proton-proton chain reaction, is sustained by the sun's immense gravitational pressure, which compresses the core and provides the conditions necessary for nuclear fusion to occur. Question 3. How does energy generated in the sun reach the earth? Through conduction, B. advection, C. radiation, and D. convection. The correct option is C. radiation. The energy generated in the sun reaches the earth primarily through electromagnetic radiation, predominantly in the form of visible light. This radiation travels through the vacuum of space at the speed of light. Upon reaching earth, it passes through the atmosphere largely unhindered, where a small fraction is reflected back into space and the majority is absorbed by the surface. Question 4. How long does it take sun's light to reach earth? Is it instantaneous? B. 8 minutes 20 seconds, C. 8 seconds, and D. 8 hours. The correct option is B. 8 minutes and 20 seconds. Light from the sun, traveling at the speed of about 299,792 kilometers per second, takes approximately 8 minutes and 20 seconds to reach earth. This duration is known as the light travel time. Despite this seemingly short span in astronomical terms, it represents the immense distance between sun and earth, which is about 150 million kilometers. Thus, sunlight we see on earth actually left the sun over 8 minutes ago. Question 5. How long does it take sun's light to reach the last planet in the solar system? The options are A. 4 hours 6 minutes, B. 3 hours 30 minutes, C. 7 hours 50 minutes, and D. 2 hours 40 minutes. The correct option is A. 4 hours 6 minutes. Due to Neptune's average distance of about 4.5 billion kilometers from the sun, light takes approximately 4 hours and 6 minutes to travel from the sun to Neptune. Question 6. What is the sun's approximate age? Option A. 2 billion years, B. 10 million years, C. 4.5 billion years, D. 1 trillion years. The correct option is 4.5 billion years. The sun is approximately 4.6 billion years old. This age is determined through various methods, including radiometric dating of meteorites, and analysis of the sun's composition and evolution. The sun formed from a collapsing region of a molecular cloud about 4.6 billion years ago, along with the rest of the solar system. It continues to shine by converting hydrogen into helium through nuclear fusion in its core, a process that has sustained it for billions of years and will continue for billions more. Question 7. What is the approximate diameter of the sun? The options are 2.4 million kilometers, 1.4 million kilometers, 5.4 million kilometers, and 400,000 kilometers. The correct option is 1.4 million kilometers. The sun has an approximate diameter of 1.4 million kilometers. This measurement makes it about 109 times the diameter of Earth. Which is the outermost layer of the sun? Chromosphere, convection zone, radiative zone, corona. The correct option is D, corona. The corona is the outermost layer of the sun's atmosphere, extending millions of kilometers into space. It is visible during solar eclipse as a pearly white halo around the sun. The corona is extremely hot, with temperatures reaching 1,000,000 degrees Celsius, much higher than the sun's surface below. Its dynamic nature is driven by the sun's magnetic field, causing eruptions known as sun flares and coronal mass ejections. Question 9. Layers of sun are divided into two, the inner layer and the outer layer. The outer layer consists of the following. Arrange the layers starting from the innermost and ending with the outermost layer. 1. Transition region, 2. Corona, 3. Photosphere, and 4. Chromosphere. The options are A. 3, 4, 1, 2. Option B. 2, 3, 4, and 1. Option C. 1, 2, 3, 4. And option D. 4, 1, 2, 3. The correct option is photosphere, followed by chromosphere, transition region, and lastly corona. The photosphere is the sun's visible surface extending from its center to about 400 kilometers above. It displays granulation across its expanse. Above it lies the chromosphere, spanning from 400 to 2100 kilometers, where temperatures vary, reaching their minimum at the base and increasing toward the top. Beyond the chromosphere is the transition region, a narrow 100-kilometer layer where temperatures sharply rise. Lastly, the corona, starting approximately 21 kilometers above the photosphere, reaches temperatures exceeding 500,000 degrees Celsius. Question 10. Where does a nuclear fusion takes place inside the sun? Chromosphere, convection zone, core, or photosphere? The correct option is C, core. Nuclear fusion takes place deep within the core of the sun. This region at the center of the sun is characterized by extremely high temperatures, around 15 million degrees Celsius, and immense pressures generated by the sun's gravitational pull. In this environment, hydrogen atoms fuse together to form helium through a process known as proton-proton chain reaction. This fusion process releases vast amounts of energy in the form of photons, which eventually make their way to the sun's surface and into space as sunlight. Question 11. What phenomenon causes the sun to appear to have a varying number of dark spots? Sun flares, B. Sunspot, coronal mass ejection, and D. Solar smudge. The correct option is B. Sunspot. Sunspots are temporary dark areas on the sun's surface, typically cooler than the surrounding areas. They appear darker because they are regions of intense magnetic activity where magnetic field lines inhibit the transport of heat from the sun's interior. Sunspots often occur in pairs or groups and can vary in size from small spots to large complexes visible from the Earth. They indicate areas of concentrated magnetic flux and are associated with solar flares and coronal mass ejections, which can affect space weather and communications on Earth. What is astronomical unit? Mean orbital distance of Jupiter. B. Mean distance between center of Sun and center of Neptune. C. Mean diameter of Sun. Or D. Mean distance between the center of Sun and center of Earth. The correct option is D. Mean distance between center of Sun and center of Earth. An astronomical unit, or AU, is a unit of distance used in astronomy defined as the average distance between Earth and the Sun. It provides a convenient measure for distances within the solar system approximately equal to 149.6 million kilometers. The AU serves as a standard for describing planetary orbits, asteroid distances, and other astronomical distances on a human scale. It helps astronomers compare and understand the vast distances between celestial bodies in our solar neighborhood. Following are the layers from the Sun's inner layer. Arrange the layers starting from the innermost and ending with the outermost layer. 1. Convection zone. 2. Radiative zone. 3. Core. The options are A. 1, 3, 2, B. 1, 2, 3, and C. 3, 2, 1. And the correct option is option C, that is core, followed by radiative zone, and lastly convection zone. The inner layers of the Sun consist of the core, where nuclear fusion generates energy at extreme temperatures. Surrounding the core is the radiative zone, extending from the core's outer boundary to about 500,000 kilometers, where energy moves outward through radiation. Above this lies the convection zone, spanning from 500,000 kilometers to the Sun's visible surface. Which layer of Sun's atmosphere is typically observed during a total solar eclipse? Corona, photosphere, convective zone, and chromosphere. The correct option is A, corona. During a solar eclipse, the corona of the Sun becomes visible as the Moon passes directly in front of it, blocking the Sun's bright disk. The corona appears as a faint pearly white halo surrounding the Sun, extending millions of kilometers into space. This outermost layer of the Sun's atmosphere is characterized by extremely high temperatures exceeding 1 million degrees Celsius. Solar eclipses provide a rare opportunity to observe and study the corona's structure and dynamics, including its magnetic fields and solar wind emissions. Stars can be classified into 7 spectral classes based on the temperatures of their surfaces in order of descending temperature: O, B, A, F, G, K, and M. M stars are the most common type, but they are much cooler and dimmer. O and B stars are very rare, extremely hot and bright. What type of star is our Sun? A type, K type, M type, or G type? The correct option is D, G type. Our Sun is classified as a G type main sequence star, also known as a G dwarf. It falls within the spectral class G, characterized by a moderate surface temperature and yellow color. G-type stars, like the Sun, have surface temperatures ranging from 5,300 to 6,000 degrees Celsius. These stars are neither extremely hot and bright like O and B stars, nor as cool and dim as M stars. The Sun's classification reflects its balanced properties, making it ideal for supporting life on Earth. Which layer of the Sun's atmosphere is the visible surface that emits light? A. Corona, B. Photosphere, C. Chromosphere, and D. Convection zone. The correct option is B. Photosphere. The photosphere is the visible surface of the sun that emits light. It is the lowest layer of the sun's atmosphere and the layer we can observe directly. The photosphere is where the majority of sun's visible light is emitted, giving it a bright, glowing appearance. It has a temperature of approximately 5500 degrees Celsius. The photosphere is also where sunspots appear, indicating areas of intense magnetic activity. What is the name of the process by which the sun produces neutrinos? Neutrino emission, neutrino detection, neutrino conversion, nuclear fusion. The correct option is nuclear fusion. The process by which the sun produces neutrinos is called nuclear fusion, specifically through the proton-proton chain reaction. In the sun's core, hydrogen nuclei, that is protons, fuse to form helium, releasing energy in the form of gamma rays, positrons and neutrinos. During this fusion process, neutrinos are produced as the byproduct when protons convert into neutrons, positrons and electron neutrinos. These neutrinos are extremely light and weakly interacting particles that travel almost unimpeded through the sun's core into space. From the following four, what is or are the constituent or constituents of solar wind? Electron, proton, hydrogen or helium? 3 and 4, only 3, 1 and 2 or only 4? The correct option is 1 and 2, that is electron and proton. Solar wind consists of a stream of charged particles, primarily electrons and protons, emitted from the upper atmosphere of the sun, known as the corona. This plasma flows outward through the solar system at high speeds, typically 400 to 800 kilometers per second. The solar wind carries with it the sun's magnetic field, forming the heliosphere, a vast bubble that encompasses the solar system. It influences space weather, impacting planetary magnetospheres, and can cause phenomena such as auroras on Earth. What is stellar pulsation? A periodic change of sun's activity and sunspot numbers, rhythmic expansion and contraction of the star's layers, periodic change in surface temperature of the sun, rhythmic change in the classification of a star based on their surface temperature. The correct option is B, that is rhythmic expansion and contraction of the star's layers. Stellar pulsation in the sun refers to the periodic variation in its outer layers, causing slight changes in its diameter and brightness. These pulsations are driven by acoustic waves resonating through the sun's interior, a phenomenon known as solar oscillations or solar acoustic modes. Unlike other types of stars where pulsations can be more pronounced, the sun's pulsations are subtle. What is the name of the solar phenomena that occurs when particles from the sun collide with the Earth's magnetic field? Options are A. Aurora, B. Coronal mass ejection, C. Solar flare, D. Solar wind. The correct option is A. Aurora. Auroras occur when charged particles from the sun, primarily electrons and protons, enter the Earth's atmosphere and collide with gas molecules such as nitrogen and oxygen. These collisions excite the molecules, causing them to emit light of various colors, predominantly green and red. Auroras are visible near the magnetic poles and are influenced by solar activity and geomagnetic storms. What is the approximate rotation period of the sun's equator compared to its poles? 5 days at the equator, 10 days at the poles, 25 days at the equator and 35 days at the poles, 10 days at the equator and 25 days at the poles, 30 days at the equator and 60 days at the poles. The correct option is B, that is 25 days at the equator and 35 days at the poles. The sun's equator rotates faster than its poles due to its differential rotation, where different latitudes rotate at different speeds. At the sun's equator, the rotation period is approximately 25 days, while near the poles it can be as long as 35 days. This variation in rotation speed is caused by sun's gaseous nature and the complex dynamics of its internal layers. It results in the twisting and shearing of sun's magnetic field lines and contributes to solar activity cycles. What is the term for the sun's 11-year cycle of magnetic activity? Options are A, solar maxima minima, B, solar period, C, solar rhythm, and D, solar activity. The correct option is D, solar activity. Solar activity refers to the varying levels of phenomena occurring in the sun's surface and in its atmosphere. Key indicators of solar activity include sunspots, solar flares, coronal mass ejection, and solar wind. These phenomena are driven by the sun's magnetic field and occur in cycles averaging about 11 years, known as the solar cycle. Solar activity influences space weather, impacting Earth's magnetosphere, telecommunications, and satellite operations. Question 23. What is the name of the phenomenon where loops of plasma follow the sun's magnetic field lines? The options are A, granulation, B, solar flares, C, solar prominences, and D, solar sparks. The correct option is C, solar prominences. Solar prominences are large, bright features that extend outward from the sun's surface into its outer atmosphere, the corona. These structures are primarily composed of plasma, ionized gas, and are held in place by the sun's magnetic field. Prominences can be stable for days or weeks, or erupt suddenly, releasing vast amounts of solar material into the space. They are visible during the total solar eclipses or with specialized solar telescopes, providing insights into solar magnetism and dynamics that influence space weather around Earth. Question 24. What is the name of the area around the sun where its gravitational influence dominates? A, heliosphere, B, heliopause, C, heliosismology, or D, heliostat. The correct option is heliosphere. The heliosphere is a vast region of space surrounding the sun, encompassed by the solar wind and influenced by sun's magnetic field. It extends well beyond the orbit of Pluto and serves as a protective bubble that shields the solar system from cosmic rays and interstellar particles. The heliosphere marks the boundary where the solar wind, a stream of charged particles emitted by the sun, slows down and interacts with the interstellar medium. What is heliopause? Momentary pause in the emission of solar flares. Estimated time when the sun will be declassified as a G star. Heliopause is the boundary of the heliosphere, the time gap between two consecutive solar cycles. The correct option is option C. Heliopause is the boundary of the heliosphere. The heliopause is the outer boundary of the heliosphere, marking where the solar wind slows to subsonic speeds and ceases to dominate the surrounding interstellar medium. It extends beyond the orbit of Pluto, forming a spherical shape around the sun. At the heliopause, the pressure from the interstellar medium balances the solar wind pressure, creating a region of transition. Spacecraft like Voyager 1 have crossed the heliopause, providing valuable data on the characteristics of this boundary and the interstellar environment beyond. Question 26. What is the term for the release of massive bursts of plasma and magnetic field from the sun's corona? Options are A. Solar flares, B. Coronal mass ejection, C. Sunstorms, and D. Solar prominences. The correct option is coronal mass ejections. Coronal mass ejections are massive bursts of solar wind and magnetic fields from the sun's corona into space. These explosive events can release billions of tons of solar material at speeds exceeding 1 million miles per hour. CMEs are often associated with solar flares and occur due to the sudden reconfiguration of magnetic fields in the sun's atmosphere. When directed towards Earth, CMEs can cause geomagnetic storms affecting satellite operations, power grids, and communication system, highlighting their significant impact on space weather. Question 27. What is the name of the layer of the sun's atmosphere that emits a reddish glow during a total solar eclipse? Options are A. Chromosphere, B. Corona, C. Photosphere, and D. The convection zone. The correct option is chromosphere. The layer of the sun's atmosphere that emits a reddish glow during a total solar eclipse is called the chromosphere. Located above the visible surface of the sun, that is the photosphere, the chromosphere is a thin layer where temperatures rise sharply from about 4000 to 50,000 degrees Celsius. During a total solar eclipse, when the moon completely covers the sun's disk, the chromosphere becomes visible as a thin reddish ring surrounding the darkened silhouette of the moon, providing a spectacular view of this outer solar layer. Question 28. What is the average distance between the sun and earth measured in astronomical units? The options are 1.5 AU, B. 0.5 AU, C. 2 AU, and D. 1 AU. The correct option is 1 AU. An astronomical unit is a unit of distance used in astronomy defined as the average distance between the earth and the sun. It provides a convenient measure of distances within the solar system approximately equal to 149.6 million kilometers. The AU serves as a standard of describing planetary orbits, asteroid distances, and other astronomical distances on a human scale. It helps astronomers compare and understand the vast distances between celestial bodies in our solar neighborhood. What are the cellular-like patterns visible on the sun's photosphere? The options are A. Solar granulation, B. Solar cells, C. Solar honeycombs, D. Solar matrices. The correct option is A. Solar granulation. Solar granulation refers to the cellular-like pattern visible on the sun's photosphere, its visible surface. These granules are caused by convective motion beneath the photosphere surface, where hot plasma rises, cools, and sinks back down in a continuous cycle. Each granule typically spans about 1000 kilometers across and lasts for about 8 to 10 minutes before dissipating. Question 30. What is the amount of solar radiation received per unit area at the top of the Earth's atmosphere on a surface perpendicular to the sun's rays called? Solar energy flux, solar irradiance, solar flux, solar constant. The correct option is option D, solar constant. The amount of solar radiation received per unit area at the top of the Earth's atmosphere on a surface perpendicular to the sun's rays is called the solar constant. The solar constant is approximately 1361 watts per square meter. This value represents the mean solar electromagnetic radiation per unit area received in a unit time.